Hi, good evening. I'm Pasintu Prabhat Veerappan. Um, so I'm going to demonstrate distributed computing assignment here. According to the given scenario, my use case is use case 1. Um, and First, I would like to give a demonstration about this project. Um, this is a complete uh, application developed by using Java language and Spring Boot servlet and HTTP technologies. Um, Application has two phases: client side and the backend. Client side has Java application. Um, from this side, we are providing user to download files, and the other part is backend. It's developed by using Spring Boot and a few microservices running on the background. Um, Now I'm going to show you the demonstration about the project. Um, for To develop this application, I have used NetBeans IDE and the IntelliJ IDE. Uh, this is the code for the client part, actually the UI and the few other uh, features. And this is the uh, complete backend, that means complete microservices for each node. As you can see here, you can see node registry here, and node 1, node 2, node 3, node 4, and node 5. There are 5 nodes are running in the background. So uh, all these uh, services are microservices. So by using Spring Boot, let's move to demonstration. Now I'm going to run the UI. So this is the UI. Actually, this is user interface. So as you can see here, you can see that user can search items, search files, and if file is selected, then it will be applicable for here, and then user can download all these files inside our um, uh, a node folder. And so as you can see here, actually the user is already in the Asia region. So there's one node selected already, and this is today's date and time. If he or she want, they can change the select region from here. But according to the given scenario, so I'm not going to um, explain these things here, but these things are also working from my code, so I'll explain you later about these things. So according to the first use case, actually use case 1, what we have to do is first, user can add files to the folder, then it should be uploaded to the other nodes as well, that means the caching. So um, each and every node should store a copy of this file. So I'm going to show you that. So this is my upload file folder. So and there are 5 nodes also there. So if you can see, the only one file is available for this, and node 2 is also the same, node 3 and node 4 and node 5. So I'll open them like this. And I'm going to add a new file to here. You can see what will be happen. This is node 2 folder, and this is node 1 folder. And minimize this one. So I have created few files here. So I will put one file here, then it will be it should be applicable for these things. So demonstration purposes, I'm going to show you that node 1 and node 2. I'll show you the uh, files also. So I'll put this one here, and you can see that once you put the other two nodes folders also appear that file. So as the same, when you move to the node 3 file, it is there, and node 4 it's there, and node 5 it's there. So when you refresh this one, it's also there. So next thing, actually, user can download that file or any other file by using this service, uh, and uh, and once user select this file, and if he want to download, if he or she want to download this file, it should be uh, download from the nearest uh, node, that means the nearest region. So something like something I explain you, if he's in the Asia region, so the nodes should be Asian region. If he or she in the USA region, so it should be in the USA nodes. So likewise, those files should be download from uh, the reach download from the uh, nearest nodes. So if I show you that, so once user select this one, so this is the file which we um, uploaded previously. So now I'm going to download it. Once you click download here, it is downloaded, and then you can see it from my downloads. We have created folder, and here. So today, um, 1:32 p.m. That means now it has downloaded here. So this is coming from the uh, nearest node as well. Um, and uh, minimize those things. Once we move to the our microservices, I can show you that here all the details related to that the things that we have previously done. Actually, you can see, so here uh, the selected region port is 60161. It's node 1, and when you move there, so you can see that selected node is 6061. So it's same like that. That means the nearest region port, nearest region microservices running on localhost 6061 port. So that's here, and you can see how that uh, region mode has been completed here. So as you can see here, the uh, region mode number node 1, um, region ID That means I have put some region IDs here. 0 means Sri Lanka, 0 means Asia or Sri Lanka, at this moment Sri Lanka, and 1 means USA, and 2 means UK. So I have selected 3 main regions and I have put numbers for that, and also there you can see the priorities. Actually, in the node 1 you can see priority is low, and node 2 priority is also low, and node 3 priority is high, and node 4 priority is low, and node 5 priority is high. And these are the ports, all these services running in the background. So all these ports are local ports, and if I explain you how this region selected. So as you can see, region ID 0, 2 zeros are there. That means 2 Sri Lankan nodes is available for us to provide their service. But this is already uh, got something and got some request, and it's try to providing them. So that means the priority is something like high. Um, according to that, you can see this one is low. So what will be happen is my code will be selected um, uh, in between those two nodes, the lowest one. That means lowest means there are no lot of requests. It can handle some request also. So that's why uh, it selected uh, node 1 to provide this service to user. Um, so I'll explain the how mask is elected and those kind of things later. But uh, this is the way how that region was selected. Now I am going to show you how master was elected from these services. So before that, I will explain how this architecture is working by using this. First, I have 5 separate nodes running on my local machine. Like this, and assume this is UI, and this is node 1, node 2, node 3, node 4, and node 5. And this is called register node. So I'll explain it. First, if we think user um, request to download a file, that request coming from that UI into this registry node. So then this registry node check whether the master node from these 5 nodes there is a master node available. So how it is checking um, this register node already know what is the master node from these five nodes. So then it will send a ping message to the master node and wait until that ping reach to the master. Um, assume it's not uh, reached. Assume it is reached from here, and the register node get some kind of response, and then assume node 5 is the master node, then it will share that master node to this user has requested some kind of services from me, but I don't have that services already with me. So then you have to provide it. And also at the same time, what register node does is it try to understand the user's region and uh, try to find what is the uh, nearest node from all these nodes. So how it is doing is something like it is requesting all these nodes to provide uh, their priorities, node IDs, and the region IDs to the register node. Then it will then all the five nodes will vote for that. Then the register node uh, got all these responses, and it it's doing some kind of process and try to find what is the most nearest node for this user. Um, and then it will tell to the master, okay, I found the nearest node, so it is assume it is node 3. Okay, node 3 is the nearest node. So then you have to request that service from node 3, and it will be provide this uh, response service to the user. That's what I'm doing here. It's something like assume this is the uh, nearest node. So then master node knows already master node knows uh, user has requested some kind of service if we think the download file. So he knows what file that user needs download. Then it's telling this node 3 to okay user this user is try to uh, find some services from you, you have provided, and then all these details shared to the node 3, and once this is uh, then actually node 3 respond uh, register node to the okay, this is the file I have, can share it to the user. Then that response will be shared to the user. So that's what I'm doing. Assume if master is not available, so then this request is coming from the UI to the register node. It is check. It is checking the master node available or not. Then actually using pin message, then it decide okay mask is not available, something like node 5 is not in there. What will be happen is then it is requesting all the other nodes. Okay, I try to find the master node, but he is not available. So what you have to do is you have to elect a master from here and let me know who is the master. So then that request uh, share to the all these nodes x x x uh, without node 5 and then each of these nodes try to request a message from all these nodes. Node 1 request response from node 2, node 3, node 4, and node 2 request some response from node 2 and node 3 and node 4, and this node requesting some services from uh, actually all these things shared there, this one also, because they don't know who is the master. They are requesting here also node 3, node 4 and node 5, and node 4 requesting response from node 5. Then actually node 1 gets okay response from node 2, node 3 and node 4, and node 2 gets from node 3 and node 4, node 3 from okay message from node 4, and once node 1 got node 2's okay message, then it is automatically removed from the lead election algorithm. So now the reduction algorithm goes on release 3, and once node 2 get from uh, OK message from node 3, then this is also removed. And once node 3 get a message from node 4, this one also removed. And this is last person. So, but he's try to get a message from node 5 sometimes, but automatically timeout happened. Then it is deciding, okay, I'm the master. Then will let others to be, okay, I'm the master. So now you have to request all these services from me. Then that master, as you this is the master. So then is share that message to other all these three nodes and the register node. Then register node uh, already register node has a variable called master. So and inside that variable I have added the node 5's port ID. Then it will be replaced by node 4 because now node 4 is the master. Um, so I'll show you that by using this one. So after that region selected, so then as I said to you that master uh, election started here. So as you can see here, um, this registry service has requested all these requested to elect a lead election from node 601660266036 and 6064 and 6065. So if I move to the node 1, so it's 60 uh, 61. So as you can see here, uh, it is requesting um, all these nodes to uh, some responses, and after that 6064 returned OK message, and 6065 also said OK. 6062 also said OK, and 6063 also said OK. That's the uh, nodes which is having uh, highest number than the 6061. That means the uh, node fund. Then this node has been removed from the lead election automatically. Now I move to the here. So as you can see here, this node also requested some responses from 6063, 6064, and 6065. All these three nodes said OK messages. And I move to the node 3. So it has requested 6064 and 6065. All these nodes said OK, I'm available. And when I come to node 4, it has requested 6065 and 5. I come to 6065. Actually, there's another node, something called 6066, but it was already killed. Um, so that means it is not available. So then it's nothing returned actually. It has empty object here. So and it's already decided. Okay, I'm the master 6065, and share to the others also. And when you come to that register node, you can see master elected port 6065 is here, and response also returned as true. Now 6065 is the master. So all the after this, all the requests from the user actually go to the 6065 node here, 6065 node, and after that actually it's according to the that region. So uh, the responses will be returned from that selected region node to the register node, and it will be having to the viewer, that means the uh, client. And also all these communication uh, in between nodes by using HTTP protocol. So the entire application has been developed on HTTP protocol. Now I'm going to demonstrate how master elected from these uh, nodes. Actually, um, now I'm going to demonstrate the code. So first I would like to share uh, the registry node code. So as I said you earlier, so in here actually actually in here you can see ping to master method is here. So that's what I explained. So in the registry node, it's already know about the master node, and it is pinged to this node. So if it is available, then it will return something, but it's not available. Timeout uh, comes, and it decide master is not available. So that's what happened here. Within 5 seconds, if not return anything, so then it will decide there is no master available. And if master is available within before 5 seconds, it will return something. So then actually it will goes with that master. No, but If assume if there is no master, so then it should be goes to the lead election algorithm. So how that happen is here it, uh, here if something went wrong, then it should be goes to that request election is here. So actually already I have an array list. um, I have an array with all the nodes with all the nodes here 6061 6062 63 6165. So I have hard coded them in here, and then it will say okay, mask is not available, you have to elect you have to select a new leader. So that will be happen here, and port will be changed, and all the requests are uh, goes to the at all these five nodes. If we assume that node 5 is not available, then it will be not reached there, but other four nodes will be getting the request election message, and that's what I said here. So registry node said okay, mask is not available, so then you have to select a master, and that's that request election uh, service request to all these nodes. Then actually I move to the uh, node 1. So so from node registry, this will call a request election method from all other nodes. So in here, in this microservice, so request election is here. So and once this is called, so it will go to this method, and here. So I have an array list node availability, and the port I already hard coded these ports here as same as node registry, and according to the port ID, this is also requesting some response, requesting OK message from uh, the other nodes. Actually, from here, if others are not responding, so it will uh, put this I'm the master message here, and it will share that uh, it will share that I'm the master to the node registry. Actually, node registry as a master method, so it will be shared to that, and actually in here it's checking the other nodes availability actually. So if we think node 6062, 6063, 6064, and 6065. So all these uh, nodes are available or not. So if return something, then it said actually if return something, it said it's okay. So then this will not select as a leader. So all other nodes are the same techniques happen actually. uh, I have hard coded the port list here, and the check nodes availability method here as same as node 1. So if it is available in node 6063 and 6065, this will be uh, not count as a master. So if it is not available, then it will let that the uh, registry node to I'm the master. If others are not available, then this is said okay, I'm the master to the registry node, and the once that is reached to there, then it will be notified to the others also. And the third node also same scenario. Check nodes availability method is also there, and I have hard coded these uh, ports are there, and actually it's not true. So I have hard coded these ports are there, and check availability nodes here. So if nodes are if node 6063 actually port is will be iterating by here, and it will be shared that the other nodes to um, request their responses. So once they return, actually it says okay. So that will be the count as master, and it will be removed from the redirection algorithm. And next move will node 4. Node 4 is also same. Actually, it has only one port to go because 6065 only. Um, and it also has the same method, and iterating. Actually, there's only one. So, and if it is return something, okay, then it says okay, 6065 returned okay. And once I move to the 6065, there's no port, and also the availability uh, is there, and but there's no port, so then it said okay. Actually, yes, I have implemented another node to test this, and on 6066 actually this has requested something from that, but I already removed that from here to show you that this node is not available. So then actually it says 6066 already killed. That means it's not already not available as the master. So then I'm the master, and it has selected actually I'm the master. Now the master is here actually. Uh, this is not getting anything. So then it comes to here and put okay I'm the master, and also it has informed to the node registry. 6060 means node registry node. So to I'm the master, and on the master service is there here. Actually now this not registered. No, okay. Actually previously this master variable is allocated as 6066. Okay, now I have new master 6065, and again it's try to pin that uh, master because sometimes it might be also broken. So if it is happened, then it will again elected. It will again inform the other nodes to elect uh, a leader. Okay, so that's how my redirection algorithm goes. So I have explained here as well. So UI request something and it comes to registry node, and registry node knows already what is the master. If mask is available, that request goes to the master and master knows. And at the same time, it's try to identify what's the nearest region. Nearest region actually nearest nodes which is near to that region, and it's also said okay no must node to set okay this is the nearest node and request shared to that node and get a response to me. So that's what this does is. Okay, now we are going to remove this actually elected master node from this uh, cluster and try to start another process, and we'll see uh, then the how next election will be started and what will be the next master. Okay, I'm going to stop this here uh, and clear this one. This is not registry service, and I'm going to start this again. Actually detection is started here, so it is try to okay, yeah, the results is actually you must elected actually 6064. That means in here actually this was broken from us. Actually I have stopped this node 5 and then start the request again, and once that is started actually this node said okay you should start your election, and then node 1 request node 2, node 3, and node 4, node 5 to respond. Once node 2 respond or node 3 or node 4, uh, this respond okay. After that actually node 1 removes. Likewise node 2 removes, node 3 removes, node 4 didn't get any response from node 5. That was selected as a uh, node master actually. So yeah, here master elected. Now 6064 is the master, and the selected region is as you can see here selected region is 6061 also because this user is already in the Asia region. So the lowest actually I have hard coded is low and high. So according to that this region was selected. Actually region is still 6061, that means node 1, and the new master elected 6064. And now we will try to start 6065. Sorry, 6065 again. So I'm going to start it. We started here. Okay, 6065 started. Total started, and I'm going to start this again and run this one. and now master should be uh, 6065. So yeah, the master is elected. Actually 6064 return true. That means 6065 return something, and master elected 6065. That's how master election happened. Actually, once this is again started, so actually that means the highest node will be the master. Um, so once all these services get started, it will automatically restart the master node and set okay, you are the master. So that's what happened here. So previously 6064 6065 we uh, remove that one from the cluster, and then after that 6064 electron, and once again we added 6065 to the cluster, and now 6065 is a master. Okay. Now I'm going to demonstrate the region election. Actually that means the Paxos algorithm. uh, but in here I have not implemented complete Paxos algorithm. I got an idea about Paxos and I have implemented my own. Um, so according to this scenario, I have implemented my own. As I said earlier, I'll remove all these things and I'll let you know how that uh, region thing happened. Actually, from the first phase of this uh, development, actually, um, I read some articles about Paxos algorithm, and after that, I have designed my own. So actually, in here, what happened is actually first that the response from the user is reached to this node, and now we have to decide what is the most nearest node in this cluster. So what will be happen here is once that uh, request come to this registry node, it will be started uh, a service to uh, pin all these nodes. Actually, it will be used to check what nodes are available, because if we assume um, um, we have if we didn't do that, actually that means we are not pinned to that all these nodes, and we have decided okay, this is the most nearest node region node. So sometimes that might be broken, so then that will be a trouble to request those services again uh, to the registry node. So actually first I have uh, try to ping all these nodes and get some response from them to check whether all these nodes are available. If something is crashed, so then it will be removed from the my list. Um, actually, then actually it will be happen something like that. Then this registry node. So this try to ping all these nodes to okay. If you are available, please let me know. Something like that. Then, if we think something is not available, will be not return anything. So then that is removed from my uh, list. After that, uh, all these things returned. The second case will be started. Second phase is something like request voting phase. Request voting phase is request all the available nodes to response their node ID. Actually, register node requesting. Okay. Uh, Now I know you are available. Please send me your node ID and the priority, and also the region IDs and uh, region IDs and there's a module for that. Uh, Here, so node ID, port ID, region ID, and priorities, and you should share all these things with me, and will be request something, and if we assume all these nodes are available, then requesting, okay, send me your port ID, region ID, node ID, and the priorities, and all these things will be returned those details to the registry node. And the third phase will be started. Third phase is selecting phase. Actually, selecting phase is something like now the registry node knows the node ID and priorities. According to that, it will check what are the highest priority nodes and the lowest priority nodes. Highest priority nodes will be removed and lowest priority nodes will stay there. And after that, it will check, okay, I have lowest priority nodes now, and so um, according to the my region, that means I have previously I told you that I have assigned 0 for Sri Lanka, that means Asia region. So I have put 1 for USA and 2 for UK. Assume all these countries are regions, assume like that. So then it will check, okay, now this user comes from Sri Lanka, that means the Asia region. I have that 0 um, uh, region ID from that UI. So now, okay, how many nodes are available for this 0 um, uh, region ID? That means how many nodes are available for this region? That means for Sri Lanka. Assume if we have two nodes, like one is high priority and one is low priority. High priority means it already providing some kind of services to the users at this current moment. Low priority means that are not providing any service; they are free. So then it will select the free node to provide these services to the user. But assume if we have one or more free nodes, so then it will select the first uh, free node that the code found, and it will select. If we assume there is no uh, low priority nodes, all are high priority nodes. So then actually from my code I don't have addressed that part, but I have a suggestion for that. So actually what we can do is we can get a number of counts. Actually, the node providing actually if we think one node providing 5 uh, services for the 5 users, and another one is providing 4, then we can get that 4. Uh, Actually, we can have that priority number, and we can get that number to select region. But in my code, actually, I don't have that much of complex scenario, but I have some suggestions to do it. So I'll move to the code now. So actually, this is my registry node. So first, actually, uh, uh, user once user request is coming from to the here. So actually, it will be uh, reach this method. Actually, as I said, that it will be pinged directly to the all these message, all these nodes, and request those request something. Uh, Once that is completed, actually it is go to that get request with priority method, and I have already at those ports here actually 60, 61, 62, 63, 65, and so according to that, actually, if we assume all these nodes are available at this moment, so it is requesting that these data, node ID, port ID, and region ID and priority data to here. And all these things will be added to that list I have mentioned from that image. And actually, node ID, port ID, region ID, and the priority. And those things will be added to that list. Uh, if we go to this node request, actually, so this is the place where that request comes to that for this node actually. So this has that module here. So actually, uh, for this Spring Boot application, I have property file. In that property file, I have hardcoded that node ID, country Sri Lanka, region 0 and priority low. According to that, I have hard-coded all these values actually. 2, node ID 2, and the region is 1. 1 means USA, 0 is Sri Lanka, and I have mentioned these things. And node 3, it's again 0 and SA, and priority is high. And 4, UK, not 4, and region ID 2, and priority low, and 5, again USA and region ID 1, and the priority high. Um, and these things will be catched by this service, and all these details stored in there. Actually, once you go here, you can see all these data. Actually, node 1, region ID 0, priority low, port ID 6061. Node 2, region ID 1, priority low, and port ID 6062, 6063, 6064, and 6065. And you can see all these priorities and region IDs and nodes. So all these things are available here, and according to that, and after that, actually, so that the third phase comes, and third phase is selecting phase. Actually, previously I told you that uh, and all these things will be comes to this interface, and after that voting section started, and then actually checked, okay, not get region ID. Region ID means that 0, 1, and 2. 0, 1 and 2 is same as the region that user provided region id. It is gathered from here, because in here actually, if I go there, if I go to that my Java application, so show you that here here localhost 606060, that means register node. Actually I'm providing the user's region id. User region id is 0 from here, and it is gathered from here, and it will be assigned to this variable, and now I am using it here. Actually I got that Java application to here 0. Okay, then it will check, okay, if get region id equals 0, uh, all the ones and twos are removed and zeros are remaining here, stay remaining here, and after that it will check priority is low or high. Highs are removed, lows are stored, and once those are stored, the first found one will be the selected node. That's what I told you. Then uh, actually it will ping to master. That means again the master election, master, to check whether master is available. Then master is available, then all these requests goes to the master. Otherwise it will be started lead election algorithm again, and check whether lead election algorithm to uh, set a new leader. And that is about the uh, region election, that means the backsource algorithm. And I have got my own, as I told you, because I have got the concept and I have got my own here. And as I told you, all the distance matrices are available in those property files. So actually, property files, country SL or something, and region, those kind of things will be available in the property file. Each node it has those data. And that's all about this demonstration. And here I also want to notice show you that the file upload and file download part, how that will be happened. Actually file download part, once that user select a file from here, once that you select a file from here, assume we select the same file that we use, and click download button, that will be uh, call this method. That means it is goes to that node registry service. Once node registry service reach, it will check the region, as previously I told you and I demonstrated about this process, and after that it will check, okay, mask is available or not. If mask is available or not. If mask is available, that means it's being request is reach, then request download service, that means download file service will be requested. Now after that it goes here, and now we know uh, what's that node ID, and it's requesting the file. If it is not available, So then what happened? It will be uh, what master is not available, then it will be elect a master here and request all these services from that. So assume that request comes to the uh, node registry to the node 1 service, and this is the place where that service microservice is happen. Actually from here uh, I have put that folder name. This is running on local machine as I told you. So in the E directory, I have DC assignment, file save, upload files, and node one. So actually here it comes to here E DC files, and to check the requested file. We have only two files, hello uploaded to uploaded to hello files is available. If it is available, then it will be uh, share that file to the uh, as a response entity. And the same thing is there. So node 2 is also that download file service, same service, and node 3 is also have same service. Likewise, there are node 4 and node 5 also have the same service, but this file folder node 3, and node 3 means node 3 means this one. And if we go to that 4, node 4 means folder 4. Likewise, there are separate folders for that, and each and every uh, folder, it has that file, those two files. Actually we have uploaded that upload two files to that folder, and it will automatically cache to the other folders also. And then if this file is available, so it can be downloaded by using these nodes. Actually nearest node, it will be provided service, and same uh, as that upload file is also there. So once we put that file to the once we put new file to the here, it should be cached to the it should be cached to the all other nodes. That means all other nodes should have same copy of that file. So once we put that file, it will call, actually from my node register microservice, I have write a file service. So this file voucher service is check whether okay, this upload file means this one, DC assignment file set upload file is available, and there are few nouns entry created, entry modified. If entry is created, actually this will check, always checking about this folder, and it will be updated, modified, or deleted or something like that. So if uh, new entry is created, it will be called this method. This method is, I have written actually um, uh, uh, to provide that file to the other nodes. Actually these are the separate mm, requests, same body actually, file name that provided from the UI, and so it will be goes to 6061, 6062, 6063, 6064, and 6065, and all these responses, and it will be uploaded to that actually node service. And upload means this service, and it will be uploaded to this one node 1, and when it comes to the here node 2, when it comes to node 3, 4, likewise all these uh, files will be added to the folders. So that's how that caching and those kind of things happen. That's all about my demonstration. Now I'm going to uh, share these uh, questions. I have demonstrated my solution and I have explained everything that the communication protocol is HTTP protocol. I have already mentioned that. And I have explained that how mass selection happened and simulate the scenario. And once I have simulated also that once that mass node is not available, so then how that election will be started again. And once that previous master node is available to that cluster, it will be not taking as immediately, but when it comes next process, so it will be counted as a new node, and sometimes it might be a master node uh, once it is available. So I have mentioned all these three scenarios actually: master node, first initial master node starting phase, and the master uh, removed from the cluster, and you will check whether actually how lead election algorithm again started. And after that, once that the, the next lead, that means the uh, latest leader elected. uh, After that, some nodes are available. So then how that nodes will be counted for that cluster. So I have mentioned all these things. And Actually, I also shows that how that node gets all these roles, and how master joins to that cluster and those kind of stuffs. And I have mentioned that one. I have showed that Faxos algorithm, and how that voting process is happen, and the distance matrix. I have showed all these distance matrices in my property files. And Actually, I have demonstrated that explain the code, how the same code can be used, how you design the code in such a way that roles can be drawn during the runtime. So I have uh, mentioned all these things in my demonstration, and also I have uh, explained all these things by using codes, and I showed this uh, the whole information is stored, and uh, actually, from my demonstration, I don't have this situation. This is not implemented by myself. So show how redundant nodes for same location can be maintained in a simulate the failure in one location, and show how redundant node will pick up when the next request come to that location. Actually, my region selection is not working like that. So but in the demonstration I have mentioned some solution for that. So, and explain how the priority works. Why did you introduce priority concept? So I have mentioned that in my demonstration also, but if I tell you it again, so I explain how the priority works. Actually, I have explained these priority works by using my uh, code. And why did I introduce that priority concept? Because again, it will be easy. It will be easy to handle that situation where uh, uh, user traffic and those kind of things. Because sometimes if actually this content network is designed to provide some faster, so it's provide some faster service to the users. So actually, what they are expecting is something like provide some fast uh, service. So this priority concept is also help to provide that faster service because uh, if we have multiple nodes for the same region or same location, then we can divide all these customers to those nodes, and then it will reduce that heavy traffic for this node and the user request. Assume that if we have a lot of request to that service, so then that will be redundant and that will be divided to all these services. So if we have priority, so we can assume we can put that priority high, priority low, priority medium or something. So then actually we can if one user comes to the one user requests something, we can check whether okay, uh, this region can be provided that service can be provided because uh, if we have some low priority node or medium priority node, then we can allow that users to enter that node and request. Then it will be uh, uh, achieve the goal of this content delivery network. Uh, it will be help to achieve that actually. Uh, so this is my demonstration. Thank you very much for uh, these things actually. And I just want to mention that I have learned a lot from this development. Actually, uh, I have read a lot about the content networks, how that uh, service providing to the customers and those kind of things. And uh, this is the final of my demonstration. And thank you very much. Thank you.